Okay, so obviously, as you can see by the title, my presentation is about computer science and meteorology. These are two majors that I've been interested in for most of my life. For the average young boy growing up, you figure out pretty quick how you're going to be defined going into teenagehood, whether it's football, basketball, speech, drama, band, whatever it is, they're pretty routine interests. But for me, it's always been different. But I don't really like the term different so much. I prefer the term forward thinking. If professions defined a person, the two for me would be meteorology and computer science. I always wanted to be more and do more with what I did, but I didn't have the opportunities like any other student had, where you had sports teams or clubs or stuff like that. So I really had to kind of figure out my own way and do things on my own as far as what I wanted to do. While these are two different majors, they can be directly correlated in a way to, with a variety of jobs to suit my interests. With meteorology, meteorology is defined as the branch of science concerned with forecasting the weather and the process and phenomena of the atmosphere. Especially, you have meteorology with severe weather, hurricanes. There's a variety of kind of interests you can go, and it's the same way with computer science, which is obviously just the study of computers and how they can be used. These are two very flexible majors to where you have so many different opportunities and outlets you can take to kind of find where you want to go. So how do you kind of combine these? It surprises you because they are very correlated in a way. There's a large subset of jobs that one could go into in both the public and private sectors, whether it's a government desk job to a support job to a public facing personality. For computer science, my main interest has always been trying to develop solutions to solve problems at hand. While I say problem, I mean this in a broad sense. Sometimes it's not always a problem, but rather improving an already existing user experience. I've enjoyed it most when applying it to meteorology, which is why it's important for me to find one that correlates the two in a broad way. For the public sector, the obvious choice it would be the National Weather Service, which is a organization within NOAA, which is in the Department of Commerce of the executive branch. Which this is one big hierarchy. There are so many different organizations that go under the Weather Service. Nationwide, you have 122 weather forecast offices that cover basically all of the states. In Iowa, we have 5 that cover the area that are in Des Moines, La Crosse, Quad Cities, Sioux Falls, and Omaha. They all cover about roughly 30, 40, 50 counties depending on where you're at. And then at the national level, you have the bigger organizations like the National Hurricane Center, which obviously forecasts the tropical storms, hurricanes that impact the nation, and you see them on the news when you have a hurricane event. The Weather Prediction Center, which kind of focuses on more the broad scale surface analysis. And you also have the Storm Prediction Center, which issues the severe thunderstorm and tornado watches, and the Ocean Prediction Center, which kind of serves the marine interests. These are all organizations which, in a kind of broader scale, national centers for environmental prediction, they kind of oversee all of these national level organizations. And also within this is kind of the epicenter of it, which is called NCEP, Central Operations, also known as NCO. They manage a lot of the IT parts of the Weather Service over the 6 branches that they have, ranging from implementation and data services, the kind of web infrastructure, network and security, operational monitoring, and software development. They're kind of in charge of leading the innovation for the computer science side of the Weather Service. Whether it is developing new software that they use, they have their own custom-made software called AWIPS, which basically manages and puts out the forecasts, which you see on the internet. And they're also in charge of just the security elements, putting all of the weather forecast offices, whether it's in a rural area in Wyoming, they're in charge of making sure they have networking and making sure that's secure in their kind of satellite network across the nation. They also manage the Weather and Climate Operational Supercomputing System, which was approved by Congress in a multi-million-dollar package after Hurricane Sandy. I think that was 2012. To where basically during Hurricane Sandy, they realized that our hurricane predictions needed to be improved because you have kind of 2 main weather models in the nation. or internationally really, you have Europe, which has their ECMWF, which is commonly called the Euro among meteorologists, and then the American GFS, which is the global forecast system. Basically, these models are kind of the templates for the forecasts you see across the nation. Obviously, meteorologists, they kind of make their own judgment. They start with these templated computer algorithm forecasts, which has been developed over years. You basically make computer code to help understand the atmosphere, and it runs 4 times a day. The Euro runs every 2, and basically what this system does is run all of these models, whether it's the GFS or the Euro, but it also goes on to the NAM and some of the higher resolution systems which help during severe weather, because obviously when you have a tornado event, you can't have a model run 4 times a day. You have to have it run every hour. This is really the true lifeblood of weather prediction all across the globe from a technological and human perspective. The Weather Service, public organization, really leads the way. They field thousands of forecasters and other technology, creating an impact and solution indirectly affecting so many people. At each of the 122 weather forecast offices, they also have a science and technology officer at these offices, which basically is the IT director of the office. They kind of oversee the computer systems. They work with the MIC, which is the administrator for each office. And with all these positions, there are so many opportunities that one could take if you have both an interest in computer science and meteorology. Because as a science and technology officer, you can use your computer science skills to apply to meteorology and apply to those skills as well. So if you really have a knowledge of both areas, it really helps out in the end. And of course, the final organization would be FEMA, which is the Federal Emergency Management Agency, basically overseeing all of the emergency management activities after natural disasters, whether it's hurricanes, tornadoes, fire weather, the volcano in Hawaii recently. They're on the scene, and once they have a disaster declaration, they have to be in charge of making sure resources get allocated to those appropriate areas. And in the private sector, there are many more organizations which are more business oriented. Obviously, you have anything from weather consulting companies. Weather Decision Technologies is in Oklahoma. They provide kind of consulting services to anything from Major League Baseball to businesses needing those specialized microcast forecasts. And then you also have WHO, broadcast media organizations. You have so many television markets across the country, whether it's Des Moines, KIMT, and Mason City. Each market has about 3 or 4 stations, and if you apply 3 or 4 meteorologists, you can have anywhere from 12 to 16 meteorologists working in a single television market out of the hundreds across the nation. And then, of course, you have the Weather Channel and the Weather Company, which this is kind of a big operation that's going on because they've undergone a lot of changes. The Weather Company also oversees WSI, which they run their own private scale computer models, which kind of rival the Weather Service in the public sector a little bit as far as providing more high resolution forecasts. These feed the software that media outlets use for their forecasts. If you see those weather maps on the 6 o'clock news, or they're doing a severe weather forecast, the graphics that you see by there are built by the Weather Company, and of course they have Weather Underground as well, which they have tens of thousands of personal weather stations across the country. This data that they collect from users just like me, because I have a weather station too that I provide for Weather Underground, they can use this data to power their computer models and really create a microcasted model approach with what they're doing. So it's really kind of incredible what technology these companies use, especially with the Weather Company, because obviously they just don't do the Weather Company. They also provide the software for WHO, KIMT, practically every TV station in the country. And WDT also makes RadarScope, which is a well-known radar application on just your phones and devices that you use, so you can look at the weather, you can look at the radar, and kind of see what the current situation is outside. For myself, I've been able to kind of get a jump start into this whole kind of atmosphere of weather and computer science with what I do with the Weather Network. This is the Iowa Weather Network. I created this in 2008. It's gone through a big evolution. This was the first logo I made for it when I first started. and it's really evolved into one big whole setup. My goal with the network was to provide accurate, reliable, and local information in a convenient setting through the likes of social media, modern technology like websites, live streaming. This is the office that I have at home right now. And yes, that is a lot of displays. I think there are 15 in total on 3 computers that I've built over time. I've been blessed to have a lot of resources to do that. And from what I can gather with this, basically this is the epicenter of a big live streaming operation. So with the 2 clicks, basically, I can go live on Facebook, Twitter, and Periscope, and really just one big operation from a single computer. From this computer, I can do live streaming, I can pull up cameras from the DOT. Basically anything I need to access, I can do it from one computer while also doing radar from another. And while I'm doing all of this, I can also see traffic cameras, as you can see, so I can see a quick glance of what's going on in Omaha. Say if we have a storm in the Quad Cities that we're covering, I can also see that storms are rolling into the Council Bluffs area. This is a big situation for Iowa because Iowa has such a unique weather situation. In the spring, we can have severe weather and tornadoes on one side of the state, while dealing with winter weather and blizzards on another. We dealt with this just this winter where we had that kind of situation. So it requires a very unique setup and kind of knowledge of what you're working with when you're doing these situations. With the Weather Network, I'm able to conduct a variety of roles and tasks. I oversee all of the weather forecasting operations, but I also work with about 5 other people. One of them is a meteorologist near the Iowa City area who is looking to get into the National Weather Service, but with such a tight job field that he's giving us kind of his consulting services. We also have a meteorologist in the Council Bluffs area. And what we do during severe weather operations like this, we cover 99 counties. Really a big area to cover, so trying to understand forecasts ahead of severe weather, it can be very exhausting in the springtime especially. For example, just this spring we had to do a severe weather forecast where perhaps the eastern side of the state might have an elevated risk for large hail, damaging winds, and tornadoes, while we have blizzard warnings in northwest Iowa. That's a very kind of typical thing for us to deal with, and you really need manpower to do all of these operations because you have to be worried about communicating the large hail and damaging wind risk while also analyzing what's the winds going to be like, how much snow are we going to get, because in Iowa, forecasting snow is so complicated. You can get 18 inches in one county and it can drop off to 6 inches in the next just because that is how the atmosphere works here, and Iowa is unique in that regard. Very tough state to cover, and we also have, during all of this, when you're trying to keep up with the forecast, you also have to keep up with the graphics, websites, and other services that we provide. You have to build this while doing the forecast as is, so really keeps you busy, and it requires other people to help you out when you are producing these forecasts. Basically, these hodgepodge set of duties that I've been kind of given myself has allowed me to take my computer science skills in managing servers, designing websites, and creating solutions and apply it to the meteorology world, serving the 99 counties of the state accurately, reliably, and locally. And of course, this is just computer science and meteorology as it is. I took this one step farther, and I was able to take a tour of the Iowa Department of Transportation's Traffic Management Center, which is basically a way that computer, civil, and atmospheric sciences can all come together. The TMC is a 24/7 essential command center. This is located in Ankeny, Iowa. It's on the basement of the driver's license station in Ankeny. I met with several staff that work in this building, and they have several primary duties, but first and foremost, they assist in proactively managing Iowa's vast transportation system, because we have I-35, which is a very heavily traveled corridor, basically from the border to the Minnesota border to the Missouri border, and then of course you have I-80 running through Des Moines. And they have several metro areas that they have to be concerned about, whether it's Des Moines, Waterloo, Cedar Rapids, and Iowa City, the Quad Cities, Omaha. So there's several areas that they kind of have to manage during, whether it's a rush hour, a winter weather event where you have tourists from Minnesota, or people coming in from Texas that don't know how to drive and cause accidents. So basically they have to kind of manage this and watch these situations on all of these roads. And what this center is designed to do, they have hundreds upon hundreds of traffic cameras in each metro area. In Des Moines, they have probably 200, to where they loop through all of these and they can pan, tilt, zoom around basically all of these roadways, whether it's mile marker 1 or 2, they have a camera there to watch. And they can see the situations as they unfold. So if they need to dispatch a DOT employee, state patrol, whatever it is, they can do that from this complex, and they're basically able to watch over the state within the center. The DOT also manages several other kind of data sets that help the meteorological community out. Like I was saying with these cameras, this was from near the Ames area just this winter with the roadway there. There was two huge pileups that happened basically north of Ames this winter, and we were able to see that unfold on a traffic camera as it was just basically domino after domino after domino falling. And with this imagery, we're better as meteorologists, we can inform the public saying, this is what's happening, stay home, don't go on the roads, because it was a bad situation, and we were able to better inform the public. Because you can show them a radar image, put a blotch of blue on a screen, they're not going to think much of it, it's just snow. But when they see the actual impact happening with these traffic cameras, where it's happening right in their backyard, they're much more likely to take action based off of it. They also manage these road conditions maps, which is basically sector by sector of the public roads. Each plow driver inputs this data so they can say whether it's completely covered or if it's dry or whatnot. You can see, obviously, with the legend, you can see some of these roads are snow covered, but these areas in orange are where it's not advised at this point in time. And plus, they close the roads, and basically that helps us inform the public to where here's where the worst roads are, here's what to expect as you head out the door. And they're much more likely to take action based off of these types of maps instead of just putting up a radar image or saying it's going to snow here at this time on that kind of graphic. They're not as likely to do that. And they also manage if you've ever traveled a roadway in Iowa, you've guaranteed to see a system like this. This is called a roadway weather information system. It is basically one big weather station. It collects anything from temperature, wind, pressure, visibility, road temperature, traffic volume and speed, and then of course even anything from soil temperatures as well. This data is just more data to have us work with, because we don't have as many weather stations in the state as we should. Of course, the airport and the FAA manage several of them, but this really supplements the areas in the rural parts of the state. For example, in northwest Iowa, there's not a lot of airports in northwest Iowa where we can get those FAA weather stations. These are located basically all along the roadways, especially along 35 and 80, but they're also along these smaller highways in northwest Iowa. So we can see what the weather situation is like, if there's a big pressure drop or big temperature change, even especially with winds as thunderstorms roll through. This is really vital for meteorologists as well. And I can't emphasize just the cameras enough, especially during live coverage when we're trying to talk about storms, whether it's in just basically rolling along I-80. They usually start out in southwest Iowa and kind of propagate eastward or southeast. And as they go through, whether it's Council Bluffs, Des Moines, or Iowa City area, we can see those cameras nearly mile for mile in those metro areas. Just the other day, we had a tornado warning to the southwest of Iowa City, and we pulled some cameras up just to kind of watch the skies around those areas. So it really helps protect those areas so they just don't see a radar image blocked up, because once they actually see the bad weather moving in from those cameras, they're much more likely to take shelter in that sort of things. And social science studies has definitely supported that. There's been a lot of research because in 2011, the tornado outbreak in Alabama in the mid-south of the country, they realized we can't just throw a radar image up and expect people to take shelter anymore. There's been a lot of studies on why people don't take shelter when we give the warnings, and that's one of the things our fields have to improve upon, is how do we get people to take action? How do we get people to heed warnings? Because while we do have radar and all of these different data sets, it doesn't change the fact that we need to communicate better as meteorologists, because we are scientists, but we haven't always been the best communicators as far as the social sciences go. Basically, to kind of conclude from that, in this age of progressivism and rapidly paced technological advances, someone has to lead the charge, combining creativity, prior knowledge, and critical assessments of an environment to create solutions to these problems posed. Computer science, while considered an single major, is best suited and can be applied to basically any other area, as you can see, whether it was with computer science, with meteorology, civil sciences, with the roadways. There's so many outlets you can take with this, and it's the same way with meteorology because they can be combined in other areas. For example, an offshoot of computer science is also management of information systems, which goes into business. There's so many different routes I can take, and I've realized that as I've gone through the last couple of years is that while you're selecting a single major, you're not strung to a single career. There's so many different outlets you can take with it, and as I head off to college, I'm much more better prepared for those kind of situations as they come up. They correlate well in the regard that computer science acts as the platform and catalyst for these meteorological operations, and there's just so many opportunities you can take. So that is my presentation.